Hello everyone. How are you all doing today? So, I hope all of you are doing good. Before we dive in, I want to make it clear to you that I won't go in details of topics we have already covered. If you have any confusion, feel free to ask me questions. I will address them. So we have important topics to cover today. Let's get started. So let's take a scenario to understand better. Imagine we have a login page. Okay. So we have a login page. This page was released today and the URL is available on Confluence. Let's say it's www.something.com. On this login page, there is a side panel where there is username, password, and a login button. So let me ask you this. Where can we find this URL in Confluence? And what's the folder name developers use to upload the links? So the answer is the development URL or branch related folder. So the developers generate URL after a build trigger. So after a build trigger, it generates a URL. This URL is then shared with the latest tests with the test lead via email and uploaded into Confluence in a designated folder. So then it is uploaded into a Confluence folder. The test lead accesses this folder and begins testing. So for testing, first he runs a smoke test. Suppose the URL is now live, and as a test lead, you have been asked to conduct a quick smoke test on this login page. So, what is a smoke test, and what steps you'd follow? So, a smoke test includes functionality check and no documentation. So, a smoke test involves critical functionality check and which will have you will quickly verify whether the login button, continue button, or other major features are clickable and functional. And for no document needed, it's like there isn't this isn't a deep and detailed testing. It's about ensuring that basic operations work and that the page doesn't crash. So applying smoke testing to the login page, there is a button there called My Account with a drop-down menu containing Login and Register. During your smoke test, you click on this button to ensure that they are working. For example, if you click register button and it doesn't respond, you have found a defect. Now for reporting and fixing defects, as a tester, you report the register button defect to the developer. The developer fixes it and generates a new URL. The updated URL is uploaded to Confluence for further testing. So you report, the developer fixes and updates. Sorry. So what's your next step as a tester? You will conduct now a sanity testing. Let's dive into sanity testing. Once the developer fixes the issue, you will retest the register button and check for impact. So for to retest the register button, this ensures the defect is resolved and the button is now functional. Then since register is linked to login and my account, you ensure those features are working properly and haven't been affected by the fix. Sanity testing is a quick check like smoke testing, but it focuses on verifying specific fixes and their effects on related modules. Now there is a difference between smoke and sanity testing. So smoke and sanity. Like smoke testing verifies critical functions, whereas the sanity testing verifies fixes and related areas. It is done after new builds, and the sanity testing is done after defect fixes. It is a broad process and it is a narrow and focused checking. Think about when WhatsApp crashes for some users, but for works for some other users. What do? You uninstall and reinstall to see if it works. That's similar to sanity testing. You ensure the fix works for you. You check if the fix hasn't disrupted other features. Now let's simulate this process. Imagine following a scenario. You have received a new URL for the login page. The register button is now fixed. As a tester, you will retest the register button, check login and my account for any impact, and if everything works fine, then sanity testing is a success. So you understand till now how to identify URLs in Confluence, how to perform smoke testing, to verify basic functionality, and sanity testing. to verify defect fixes and ensure no negative impact on related features. Remember that smoke and sanity tests are essentially for delivering quality software quickly. Do you have any questions on it, further clarification on anything we discussed? Okay, then let's move on to another topic. Now, developers primarily work on code base, which is the repository where all the application source code is stored. They utilize tools like Angular, a framework that enables them to create dynamic and interactive web applications. So the following steps outline this process. Mm, the first one is local development. The second one is testing on local code base. The third one is pushing code. The fourth one is code review meeting. So the developers begin by creating a branch in the version control system. For example, GitHub. This branch acts as a sandbox environment where they can independently write, modify, and test their code. While writing the code, Angular features such as the two-way data binding allow developers to see real-time changes. On the left-hand side of their environment, they write HTML, JavaScript code, and the dummy user interface is generated on the right-hand side. Now, on the second step, that testing on local code base, developers perform unit tests, integration tests, or regression tests within their local setup. For example, they check that individual components like the submit button or username field function correctly. These tests ensure that any new feature doesn't break the application locally. Now then they push the code to the GitHub. Once satisfied with their local testing, the developers pushes the code to a branch on GitHub. This branch is isolated from the master branch, preventing unfinished or unstable code from affecting the main application. Then after pushing code to GitHub, the branch is reviewed during a code review meeting. So these are the process. After that, the technical lead oversees the process and ensures that the code meets quality standards and adheres to the required functionality. Other developers may join this meeting to verify that the new code doesn't conflict with existing modules. These are the four steps. Now, the fifth one is the integration to the master branch, and the sixth one is creation. In integration, after approval, the technical lead merges the branch into the master branch. The code is integrated into the main application where different modules or features are connected to work together. Then the repository link is generated to track changes and provide access to updated application. Now the DevOps process. For this, there are a few steps. They are parsing code, Jenkins, URLs, and communication. First, the repository link is handed off to the DevOps teams. Their primary role is to ensure seamless deployment of the application across environment like dev, QA, and production. Then the DevOps team uses Jenkins, a tool that automates the build and deployment process. In Jenkins, the repository link is entered. Then it compiles the code, runs additional automated tests, and generates a build. A build trigger option in Jenkins ensures the smooth deployment of the application. Once the build process is complete, Jenkins converts the codebase into a user interface, making the application accessible via URL. Then the your generated URL reflects the specific environment, like dev environment, staging, or production. For example, the dev environment URL can be like www.store.com/dev, or the production URL can be www.store.com/prod. After that, in final communications, the DevOps notifies the test lead via email or tools like Confluence, providing the finalized URL for testing. This marks the transition from the developer phase to the tester phase. Now let's go to tester's role. Sanity test. Then unlike developers who test in the code base, testers focus on the build, which is the deployed application. In smoke testing, they ensure that the application is stable and critical functionality works. For example, on registration page, the tester would check if the URL redirects to the correct page and confirm that the form fields like name or email are functional and interactive. Then in sanity testing, they verify specific functionality after recent changes or bug fixes. This involves testing both the testing fixed feature and its impact on related components. For instance, if a login button is previously non-functional, the tester would verify the new button works and check related modules like password recovery or session management for any adverse effects. Then the testers go deeper into application behavior, covering edge cases and unexpected inputs. So the key difference between developer and testers are the developer works on code base and the testers works on the build. Then the developers use Angular, GitHub, whereas the testers use user interface, URLs. The developers use unit testing, regression testing, integration testing. The testers use more sanity, etc. Then they can use PC or server, whereas the tester uses QA, dev, etc. By following this detailed process, developers ensure a robust application and testers confirm that the end product meets requirements and is ready for deployment. This cycle fosters collaboration across teams and maintains the application's overall quality. Now, why developers use local PCs? Developers initially write their code on their local PC. This is their personal workspace where they can edit, compile, and test their code locally. Once the code is finalized, it is uploaded to a version control system like GitHub. GitHub acts as a central repository where all code versions are stored systematically. This ensures that every change, update, or fix is tracked and can be retrieved if needed. Think of it like saving your progress in a video game. Every stage of your game is saved in a separate slot so you can revisit and adjust without losing previous progress. Now, for versioning and folder organization, there are three steps like upload, find defects, then separate folders. After completing the first version of code, like version 1.0.1, it is uploaded to a folder A on GitHub. Folder A. This version represents the initial build, which testers will verify. Now, testers might discover defects during the testing phase. Developer fixes this defect and create version 1.02, 1.0.2, 1.0.2, which is then saved into folder B. So, why we use separate folders? We use it to prevent malfunctions. So uploading modified code to the same folder could lead to misaligned code. causing the entire application to malfunction. Then the separate folders ensure that each version of the code is stored independently. This way, previous builds remain intact and can be referred to or rolled back to if it needed. Imagine if you are editing a document and saved over the original file. If the edited version has errors, you can no longer access the original version. Similarly, keeping versions in separate folders avoid overwriting. Now, how version control helps? If version 1.0.3 is not working and has coding issues, developers or testers can import files from version 1.0.2, the previous version, to fix it. This process is smooth and error-free because earlier versions are safely stored in a different folder. So we use GitHub as a version control system. It can store every version and track changes and ensures collaboration among teams without conflicts. So let's go to system integration testing, SIT. It is an environment where all the modules of application are integrated and tested as a whole. It is used to verify the interaction between modules to ensure they work together seamlessly. Now, there is a dev environment and there is a city environment. In dev environment, individual developers or team build and test smaller features here. So in dev, first they write code, then they test individual features like the login page, the shopping cart, etc. Then they deploy these features to the dev environment for initial testing. Then in the city environment testing, all individual modules are integrated into one complete system. A single URL link is generated that combines all features for comprehensive testing. So the goal is to ensure intermodal communication. For like clicking add to cart should redirect correctly to the shopping cart page. Then verify at the end-to-end user flow is functioning correctly. So what is end-to-end testing? The end-to-end testing, it checks entire workflow. For example, log in to the application, add an item to the cart, proceed to checkout, complete the purchase. At every step, ensure the system redirects to the correct page and behaves as expected. So, for example of interaction testing, you can hover your mouse over laptops and notebooks and click show all laptops and notebooks and verify it lands on the correct product listing page. Then the testers are assigned specific modules like tester A is assigned register and login. Then tester B is for shopping cart and checkout. No single tester is responsible for testing the entire application. Instead, tasks are distributed to ensure thorough testing for every module. So, why separate testing is critical? By assigning specific modules, testers ensure that the focus testing reduces the chances of missing bugs, so it increases the accuracy. And also, the parallel testing speeds up the process for efficiency. Once all modules are tested and verified, the application is ready for deployment. So, we learned about deployment environment, system integration testing, and why version control and use separate folders, right? Now, let's talk in details about system integration testing. It is performed to ensure that all the modules and components of the system are properly integrated and communicate with each other as expected. Think of it as testing the connection and data flow between features. It ensures that when individual parts come together, they function as one cohesive unit. Here, the objectives are to verify the integration of all components and to ensure the system behaves as specified in the functional requirement document or FRD, and to identify and resolve any issues in communication or data exchange between modules. So how it's done? In step one, test connection. In step two, perform end-to-end testing. And step three, compare to FRD. So in step one, you test the connection between different features. Like if you click on a search button, what does it trigger? If it triggers the correct action to retrieve the desired results, does the data flow correctly between the database backend and front end? Then in step two, it means to test the entire flow from start to finish. For example, logging in and searching for a product, adding it to the cart, and completing the checkout process. For step three, they cross-check that every feature listed in the FRD is presented and working as intended. Imagine you are building an online bookstore. Sheet ensures that when a user searches for a book, the query is sent to database. The database retrieves the result and the result is displayed properly. So the first the query is sent to database. Then the database retrieves the correct results. After that, it is displayed. If any part of this chain breaks, the system integration testing will catch it. So, there are some common issues identified in system integration testing, like missing features, incorrect data flow or communication between modules, integration errors such as mismatched data formats. So, SIT is about verifying connections and interactions. It ensures that the application behaves like a well-oiled machine when all parts are integrated. Okay, now what is system testing? System testing is performed after SIT and before user acceptance testing. It is focused on validating the entire software application as a whole to ensure it meets the specified requirements. Now, there is a difference between SIT and system testing. SIT focuses on integration and communication between components, where the system testing checks the entire system's functionality in a single entity. Okay, now there are few steps for system testing. For step one, after start the system testing. After SIT is complete, then step two is to verify. Verify the system against the functional requirement documents. Does the application meets all the functional requirements? Then in step three, perform multiple type of testing. Perform testing to ensure that the whole process is completed. Now there are different types of system testing. Like the first one is graphics user interface testing. Here it focuses on the visual components of the user interacted with. So it focuses on visual component. Here the tester test are the buttons, icons or links are working as expected. Are the header, footer and layouts displayed properly? Is the font size, style, and color consistent with the design specifications? For example, we can ensure the search button is clickable and the search bar displays the results correctly. Then comes the functional testing. It focuses on the application's functionality. Here, the tester test do all features perform their intended tasks. For example, they test the add to cart button to ensure items can be added and check if the checkout process completes successfully. Then comes the non-functional. In the non-functional, they test performance, reliability, and usability. Here they check can the system handle high traffic? Is it loading with acceptable time limits? After that comes usability testing. Here it focuses on user experience. Here the test is the application is intuitive and user friendly. For example, they can ensure that a user can navigate the website without any confusion. Now, there are several testing techniques are used in system testing. So, testing techniques. They are smoke, sanity, and regression. In smoke testing, it is performed after receiving the initial build to ensure basic functionalities work. Then in sanity testing, it is performed after bug fixes to verify that the specific issues are resolved. Then in regression testing, they rerun the test to ensure that the recent changes haven't the broken existing functionality. Then if a bug is identified, the tester reports it to the developer. The developer fixes the bug and sends it to the tester for verification. The test lead decides which test to run after the fix to ensure that it doesn't affect other part of the system. Okay, now let's go to an online bookstore. In system testing, we test everything end to end. The user searches for a book, the results are displayed. The user selects a book, adds it to the cart, proceeds to checkout. Finally, the payment gateway works and an order is confirmed. So first, the user searches for a book. Then it shows the results. After results, he selects books. After that, he goes to checkout. These are the process. So system testing ensures that the entire application is functional, reliable, and ready for real-world use. It's the last major testing phase before the system is handed over to the user acceptance testing. So the key difference between the SIT and system testing are SIT focuses on integration and communication. The system testing focuses on entire system. Then the seed is conducted after modules are integrated, and the system testing is conducted after seed. It tests the end-to-end connectivity, and the system testing is the overall performance system. Then there is the types of testing are connection testing, whereas the system testing have graphics user interface, functional, non-functional, etc., as we have discussed. Okay, now let's dive into functional and non-functional testing. Non-functional testing includes performance testing and security testing. Have you heard about ethical hacking? If not, no worries, I will explain it in details. So, in functional testing, it focuses on the front end and the back end of the testing. For example, it has graphics user interface testing for front end and API database testing for backend. API and database testing are considered functional testing because they validate if specific functions work as expected. Clear so far? Okay. Then in non-functional testing, there is performance testing and security testing. Performance testing evaluates how the application behaves under different scenarios. For example, how does it perform when thousands of users log in at the same time, or when the network speed drops? Tools like JMeter simulate these scenarios to measure response time and system behavior under varying load. And in security testing, uh, let's take an example of ethical hacking. Think of your house as a computer system. You have friends and family as authorized users. So, friends and family as authorized. And doors and locks have passwords and firewall. Now you hire a detective to test if someone can break in unnoticed. This detective is called ethical hacker. Their job is to identify weak spots in your security so that they can be fixed. Similarly, ethical hacker can run penetration testing to simulate real-world cyber attacks. They help secure the system against vulnerabilities. In penetration testing is a cybersecurity practice where ethical hackers simulate hacking. So why do they do it? They do it to uncover vulnerabilities. and to ensure weak points are discovered. Imagine you developed a banking app for thousands of customers. A hacker finds a weak entry point. Now, what will he do? He will steal all the money. Your reputations will suffer. Customers will lose their trust and business will collapse. So, ethical hackers simulate attacks from every angle, find weak spots, and report them. Then the developers can fix those spots to strengthen the security measures. Now let's discuss about globalization and localization testing. The globalization testing ensures that your software works worldwide. For example, they can adapt to currencies like US dollar, euro, or pound, and date formats like month, date, year, or date, month, year, and different languages. For instance, if you are in the UK, prices should be displayed in pounds, not USD or euro. Now, for localization testing, it is about tailoring the software to meet specific local needs. It focuses on cultural and regional requirements. For example, like formatting content for a specific country's language, currency, and conventions. Okay, now usability testing. Usability testing ensures that the application is easy to use, it is intuitive, and it is efficient under different scenarios. Now let's go to regression testing. Regression testing ensures that the recent changes like fixing bugs or adding new features don't break existing functionality. There are two types of regression testing, unit regression testing and full regression testing. In unit regression testing, when the developers test changes in specific units of codes. It happens before deployment and is performed on the modified code base. And for full regression testing, it is a comprehensive testing of the entire application to ensure all functionalities work seamlessly together. Now, in a brief review, we can say that the functional testing ensures each feature works as intended. It includes graphics user interface, API, and database testing. In non-functional testing, it covers performance, security, globalization, and localization testing. Ethical hackers and tools like JMeter play a crucial role here. And in usability testing, it focuses on new user experience. Got it? If anything's unclear, you are feel free to ask. Now, let's start with how software update happens. Imagine you are a user. You're trying to access a website. Suddenly, you see a maintenance message. Maintenance is going on. Please check back later. What's happening here? Here, the developers are deploying a new version of the application. The older version is taken down and the new version is being uploaded. For example, in version 1.0.1, your application had just an icon, and in version 1.0.2, the icon is updated to includes phone number. When the update occurs, the system temporarily goes offline. A new URL for the updated version is generated, and the updated application with the new feature become available to the user. What happens during the code update? When the developers make changes to the application, whether they are fixing a bug, adding a new feature, or removing something, they are modifying the code. This update can potentially affect the module being updated and the other connected features. This is why testing after update is crucial. Now let's explore the key testing types that comes into play. So let's understand regression testing. Regression testing ensures that the new changes don't break any existing features. For example, there is a bug in the registration page of an app. Once fixed, the testers retest the registration page to verify the fix. They also test related modules like the login page to ensure they are unaffected. This process is called regional regression testing. Excuse me. It tests both the updated module and its impacted modules. Now, sanity testing and regression testing are similar, but they have different purposes. In sanity testing, it focuses on checking key functionalities of the impacted modules. For example, only verifying that login works after the registration module is updated. And in regional regression testing, it checks all connected modules thoroughly, like testing login, registration, and related components to ensure there are no issues. Now let's understand the difference between unit, component, and regression testing. So, in unit testing, it is done by developers. Okay, then it tests individual units of code. For example, a developer writes and tests a login functionality. And in regression testing, it is also done by the developers. After fixing a bug, developers test to ensure the updated and Ensure the updated unit works as intended. Ensure that updated unit works. And the third one is component testing. It is done by testers and it focuses on testing a feature or module in isolation. For example, testing the registration page alone without integrating it with other features. Once all modules are integrated, we perform end-to-end testing in system environment testing. This includes performance testing, compatibility testing, usability testing. The performance testing evaluates how the system performs under stress. It includes load, stress, and volume testing. Then comes the compatibility testing. It ensures the application runs smoothly across browsers like Chrome, Firefox, etc. It is conducted by external end users to access how user-friendly the application is. Okay. Then before releasing the application, there comes alpha and beta testing. In alpha testing, it is done by developers in a control environment. It ensures all critical issues are resolved before releases. And in beta testing, it is conducted in the UAT or user acceptance testing environment. It is done by selected external users and it focuses on user feedback, flexibility, efficiency, and business requirements. Let's walk through an example. Okay. Suppose a bug is found. A bug is found in the registration page. So the developers will fix the bug and send the updated code to the testers. Okay. Then the testers retest the registration page to confirm the fix, if it's fixed or not, if it's working perfectly. Okay. Then the testers ensures that the related modules like login and dashboard work correctly. Then in alpha testing, the developers verify everything works on their local system. Then in beta testing, the selected users test the application in a pre-release environment and provide different feedback. Then, then in final release, the updated application is released to the public. So from this, we can say that in summary, the regression testing ensures the new updates don't disrupt existing features. In sanity testing, it focuses on important functionalities of impacted modules. In regional regression testing, it checks all the connected modules for issues. And in alpha testing is a final check before by the developers in a controlled environment. And in beta testing, it involves external users and focuses on usability and business goal. So I think that's it for today's session. You you should revisit these concepts, relate them to real world scenarios, and don't hesitate to ask any questions. Understanding this process deeply will prepare you for different interviews and real world challenges. So we'll recap these points and dive into more advanced topics in our next class. Thank you for attention and I'll see you in the next class. Till then, take care.